Hi everyone. So in this video, we're going to work through another Year 12 Pure Maths question from the AS 2018 paper. And this question is about modelling with stationary points. So we have here a lorry that is driven between London and Newcastle. In a simple model, the cost of the journey, C pounds, when the lorry is driven at a steady speed of V kilometers per hour, is given by C equals 1,500 over V plus 2V over 11 plus 60. So for part A of the question, find, according to this model, the value of V that minimizes the cost of the journey. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level maths topics that will come up in your 2027 exams. So now that the 2026 exams are finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018 and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up. Sign up to the app and you'll be able to access all of these 2027 predictions. So when we want to minimize the cost or minimize a variable in a formula like this, so in this case, we're minimizing the dependent variable, we need to use differentiation. And if you forgot why that is, I will briefly explain why that is now. So imagine the curve for this journey with this formula. Again, we put C on the y-axis, put the independent variable V on the x-axis. Let's just say the curve looks something like that there, roughly. You've got a minimum cost down there. Now, if we draw a tangent to the minimum value or the minimum point of that curve, like so, what is the gradient? Well, the gradient there is obviously 0. So the gradient is dc by dv, and we set that to 0. So in a question where we're minimizing a formula or minimizing some kind of model, we're going to use differentiation. So we need to differentiate the curve. It probably just makes sense if we write our formula in index form first. So 1,500 v to the minus 1 plus 2 over 11 v, and then plus the constant of 60. Great. So now let's find dc by dv. So again, using our technique of differentiation, bring the power to the front, take away 1 from the power. This would give us minus 1,500 and then v to the minus 2, and then plus 2 over 11, and that would be our result there. And as we said, we need to set this equal to 0. So set this to 0, and then it probably just makes sense to rewrite the v to the minus 2 as 1 over v squared, so 1,500 or negative 1,500 over v squared plus 2 over 11 equals 0. Let's just move over that first term to the right side, so 2 over 11 equals 1,500 over v squared, and then we can multiply by the v squared onto the left side. So v squared is equal to 1,500 and then divide by the 2 over 11. We can just work out what number this will be. I will do this on my calculator right now. So 1,500 divided by 2 over 11. This gives me 8,250. We can now take a square root of that to get our answer. So the square root of that will give us the speed that minimizes the cost, and that would be a long decimal. Let me just read the question again. Do we want it in exact form? It doesn't say in exact form. I'll just leave the answer here as root 8250, and we're looking at kilometers per hour with this one. I'll just leave it like that. But if you want to give it to 3 sig figs, this would be 90.8 kilometers per hour to 3 sig figs. So you can either leave it like that or leave your answer like that there. Perfect. So that's part A, part I. Now for part II, find, according to this model, the minimum cost of the journey. Well, we know that the speed that minimizes the cost of the journey was this speed we found like down there. So we can just basically sub in that speed into our formula for the cost up there, and that will give us the minimum cost. So let's do this down here. So we can say that cost minimum will be equal to, and then we'll copy down our formula. So 1,500 over the V value that we just found. So root 8250. And then what was it? It was plus 2 over 11 V. So plus 2 over 11. And then this speed there. And then it was plus 60. Yeah, plus 60. There we go. And then we can just work this out on the calculator. So yeah, 1,500 divided by root 8,250 plus 2 lots of root 8,250 divided by 11 and then plus 60. So this gives me 93.0289, so on and so on. Since the cost is in pounds, we'll round that to 2 sig figs. So min cost will be £93.03 for this question. Just another quick interjection. If you are currently doing Edexcel A-level maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. Perfect. So that's part A now done. Now let's go to part B. So prove using the second derivative, so d squared c over dv squared, that the cost is minimized at the speed found in part A, part I. Okay, so with this question, we're going to take the second derivative. We already have the first derivative here. Let's just kind of underline that there. That's our first derivative. I write it down again here. So dc by dv is equal to minus 1,500 v to the minus 2. And then I think it was 2 over 11. Yeah, plus 2 over 11. So we'll just simply differentiate this again. So differentiate that again. So again, bring the power to the front, take away 1 for the power. This would give us minus 2 multiplied by minus 1,500. This would be positive 3,000. And then take away 1 from the power of v. This would be minus 3. And then plus the constant, that just differentiates to 0. So yeah, this gives us 3,000 over, and then v to the power of minus 3. So what we need to do now to prove that this speed we found here minimizes the cost is just simply sub it in. So sub in v equals square root of 8,250 into the second derivative. And remember, once we do that, if we end up with a positive second derivative, it means that we have minimized the curve or minimized the cost in this case. So just sub it in 3,000 over square root of 8,250 to the power of 3. I mean, it's kind of obvious it's going to be a positive number, but I'll just work out the number just to prove to the examiner that I know it's a positive number. So this would be 3,000 over 8,250 to the power of 3 over 2. It's about 4.8 well, about 4 times 10 to the minus 3. So this is about, yeah, 0.00400, etc., etc., which is obviously a positive number. So since the second derivative is positive at v equals root 8,250. Therefore, this speed minimizes the cost. Perfect. So that would be the answer to part B. Now let's go to the last part, part C. So part C just says state one limitation of this model. Now, if we look at the modeling assumptions back here, so this paragraph there, it says in a simple model, the cost of the journey when the lorry is driven at a steady speed of v kilometers per hour. Now that's the key point. The model is based on a steady speed. Now, in reality, if you're driving a lorry is not going to remain at a constant steady speed. So that is the key limitation of this model. We can't drive at a constant steady speed. So let's just write this down here. So for part C, it is impossible to drive a lorry at a constant steady speed for a full journey. So therefore the model, yeah, the model is not really great if it's only valid for a steady speed. Perfect. So hopefully that all does make sense from all of the parts in the question that we've looked at. But if you do have any questions, do feel free to drop a comment below.